Welcome to the Data Lakes for Digital Marketing and Advertising webinar. Amazon has a principle which we call working backwards. What it means is to listen and understand the customers and their needs and work backwards from that. We receive ongoing feedback from CMO organizations and want to first share the key findings with you. So let's hear directly from the CMOs. Here are just two examples of CMOs, but they summarize well the priorities which we see in the broader market. Audible is an Amazon company since 2008, and a great quote by Louis Gagnon, the CMO of Audible. The new CMO needs to be data-driven executive. That means you don't come with a brand theory, you come in with customer intelligence. And Heather Zinchak, CMO of Domo, extends the idea of the customer intelligence into the business value of CMO organizations. The CMO needs to be able to walk into the boardroom and talk about how they are contributing to the bottom line, how much money they're spending, and how much money they're making as a company. So when it comes to the big picture view, we can summarize these two major trends. So the first trend is the desire of the companies to develop deeper knowledge about their customers. This starts with a collection of data and in-housing of all customer data, understanding customers' journey to the purchase, interaction with the brand, knowing future customers and their interest and behavior, and how it does well beyond views and clicks. Collection of data at petabyte scale and efficient analysis of that data is now a new normal with cloud computing, and AWS makes it affordable for the company at almost any size. And the second trend for the brand is to create much better customer experiences. The new channels of interaction with natural language, voice, virtual reality, augmented reality, video, and high-quality, highly relevant content. This will dramatically enhance customers' experience and make the products and services much more appealing to them. So ultimately, these two main trends result in the same outcome: dramatic improvement in return of investment for marketing initiatives. And the biggest driving force and enabler is artificial intelligence and machine learning. It's at the foundation of this process. So we just talked about the strong trend and business need to accumulate the data, derive the insights, and to use it to drive business outcomes and make future decisions. So let's enter the concept of data lake and discuss what are the peculiar things about marketing and advertising data lakes which make them more unique. So overall, the AWS definition of data lake is as follows. A data lake is a centralized repository that allows you to store all of your structured and unstructured data at any scale. You can store your data as is without having to structure the data, run different types of analytics, from dashboards and visualizations to big data processing, real-time analytics, and machine learning to guide better decisions. Why implement data lakes for marketing and advertising? An Aberdeen study saw organizations who implemented data lake outperforming similar companies by 10% in organic revenue growth. Typically, the data flows from the bottom of the data lake. It gets processed, stored, enriched, and transformed as it's being prepared for analysis and machine learning. So what makes marketing and advertising data lakes special? First, in many cases, data lakes consolidate data from many geographies and present a unified view of the data. And second, data lakes are compliant with local data privacy laws and offer a great degree of security, compliance, and auditability. Data lakes are open by nature. In many cases, CMO organizations work with SaaS software vendors for enterprise marketing. SaaS tools are simplifying CMO experiences, for sure, but they're perceived by some customers as black boxes and constrained to the choices of analytics and machine learning offered by the vendors. Therefore, customers lack the ability to extract fine-grained data from these systems. Openness of marketing and advertising data lakes allows you to store and organize data in any format, bring any open source or otherwise tool for analytics, machine learning, and scale economically into exabytes. So when marketing and advertising teams considering launching a data lake project, here are the main business and technical considerations. First, it's a separation of PII versus non-PII data and ownership of non-PII data. Personally identifiable information, or PII, is any data that could potentially identify a specific individual. Any information that can be used to distinguish one person from another can be used for de-anonymizing anonymous data, and it can be considered as PII. In many cases, PII and non-PII data is being managed by separate teams, and the data lake security separates the responsibilities and offers that functionality. So second, every customer has PII data. This is the crown jewel of the company. Sometimes it's called first-party data. And it resides primarily in CRM systems, but it can be in many other systems. Non-PII data, on the other hand, is much more complex, and some customers may opt out from using it in data lake because of the size and complexity of non-PII data. In general, non-PII data can be at least 10 to 100 times larger than PII data. So working with PII data is commonplace in AWS, and all foundational AWS services of the data lake can store and protect PII data. For example, customers in the European Union are working under General Data Protection Regulation, or GDPR, which became effective in May of this year. AWS services used in marketing and advertising data lake are GDPR compliant, and it makes it a lot easier to build GDPR compliant solutions. On the technical side of considerations, important data lake requirements to be flexible. Receive data in any format and at any rate, in real time, streaming, or in batch. Data lake will be able to store data in the original format, secure it, and then transform it into query-optimized format. And last but not the least, data lakes need to offer broad choice of machine learning technology and not limit the choice to a single framework, for example, TensorFlow. Despite the fact that 88% of TensorFlow runs on AWS, according to Nucleus Research, our customers tell us that many other frameworks are very useful for deep learning, such as Apache MXNet, PyTorch, Caffe2, and others. So here is a simple example and logical diagram of how marketing data lake operates. It's a repository for the marketing-related data across the entire enterprise. Even though different geos may operate independently and have their own independent marketing budgets, marketing objectives, marketing strategies, and audiences, practice shows that providing a global view of marketing operations via centralized marketing data lake offers high business value. In this case, unifying customer identity across multiple geographies and business lines is also done inside marketing data lake. Data comes from first-party CRM systems and other systems, and marketing teams work on the user data stored in the PI data repository. They analyze data and analyze high-value customers, how they engage with the products and services, and what makes those customers purchase the products. Data science teams typically run propensity to buy models and analyze customer data. Then they develop groups of customers, which they call audiences. And they take the data, identifiable by a key, in some cases it can be, for example, an email address, and try to find those audiences online. It can be done in really two ways. First one is by submitting the customer identifiers, hashed email address, for example, to a data management platform. Data management platform then will do the audience extension. It will be able to reach to a larger population of users on the internet, which looks similar or look alike the high value of the customers identified by a CRM. Alternatively, the PII data can be submitted directly to the social networking platform for lookalike modeling and extension. So this is just a simplified view, but frequently encountered in the real world. So now, some of the brands are actually bringing non-PII data in-house and building a data management platform inside the organization. The non-PII data is typically larger and sometimes significantly larger, 10 to 100 times larger than PII data. And it also has much higher velocity. So both PII and non-PII data are kept typically separately for compliance and audit purposes. They also have different groups of people accessing these repositories, but there is a relationship between these data sets. Non-PII data can be anonymized, and that transformation is performed using hashing algorithms. Non-PII data also are more volatile, as it can contain advertiser IDs, mobile IDs, and cookie information, which can change over time. There are also consent requirements which need to be obtained from the users for PII and non-PII data. In some cases, non-PII data can be collected directly, and it can also be purchased from a third-party vendor. Non-PII data can improve the effectiveness of advertising campaigns and can be used to cross-reference data from other providers, demand-side platforms, and data management platforms. So despite the increase in complexity, non-PII data can be very valuable for increasing ROI on marketing and advertising. So data management platforms operate on a very large and high-velocity data sets. And they were really early adopters of AWS technology, especially in the area of big data and machine learning. So Salesforce DMP, formerly Crux, is the leading data management platform that utilizes segments and activities and create audiences to increase engagements with users. Marketers can deliver more relevant and valuable customer experiences by capturing, unifying, and activating data signatures across every device, desktop, mobile, tablet, set-top, in every channel, display, social, search, and video. And all of this can be done in real time. Salesforce DMP interacts with more than 3 billion browsers and devices and supports more than 200 billion data collection events, processed more than 3 billion CRM records, and orchestrates more than 200 billion personalized consumer experiences. So Salesforce DMP infrastructure is continuously live across each customer's digital footprint, including websites, devices, apps, campaigns, and manages more than 10 petabytes of on-demand data. Observing behavior comprehensively across media, not just campaigns, reduces bias and provides clients with greater accuracy and more sophisticated segmentation for targeting analytics. So Salesforce DMP does not only require clients to use predetermined audience taxonomy, but instead it enables them to independently change the audience taxonomy on the fly as needed, so they can quickly adapt to the changing business needs. So this approach, however, puts enormous demand on a Salesforce DMP to quickly and efficiently process massive amounts of data. And the second example is IOTA is a publisher solution provider and a data provider. So the company collects and analyzes audience data that online publishers use to create advertising campaigns. So the company relies on AWS to collect and store billions of data points from more than 30,000 publishers, primarily in the APAC region. It analyzes tools to help publishers to create targeted advertising. So by using AWS, IOTA has been able to expand into multiple international markets while keeping costs low and maximizing its custom advertising revenues. So now we reviewed the concept of advertising and marketing data lake from the business perspective. So let's take a look at the underlying technology. And with that, let me allow Herman Barol to continue with the discussion around data lake.
All right. Thank you, Dimitri. My name is Hemant Barole. I am a senior big data consultant on the AWS professional services team. So let's talk about the concrete building blocks of the data lake. Now that we have reviewed the concept of advertising and marketing data lake from the business perspective, let's take a look at the underlying technologies. So at a high level, a data lake pipeline on the big data services looks like this. You have the ingest phase, the storage phase, then you process, and then finally you have the analyze and visualize stage. Now, this particular slide shows you the different services at each of the stages, where for ingest, for example, you can ingest data using services such as AWS Snowball, Kinesis, or AWS Kinesis Firehose, and so on. And for storage, you could use services such as AWS Amazon S3 or Amazon Redshift, and obviously the relational database systems. For processing, you can use services such as Amazon EMR, Amazon Athena, and Amazon AWS Glue. And for analyze, you could use services such as Amazon Elasticsearch, Amazon QuickSight, Amazon Athena, and so on. Here is a reference architecture for a batch processing as well as for a real-time processing in a typical advertising data lake. So what you see here is your traffic data such as clicks and impressions and so on is ingested from your services. That can be passed to a routing AWS service such as Amazon API Gateway, Amazon Route 53, or Elastic Load Balancers. And these can then reroute the data of your traffic to batch ingesting services such as Kinesis Firehose or a web service that can be running and be hosted on an Amazon EC2 instance. Alternatively, you can also pass this data into a streaming service such as Amazon Kinesis. Once the data has been ingested, you can have this stored into a data lake. The data lake can comprise of services such as Amazon S3 or a data warehouse like Amazon Redshift. And you can now have a view of metadata that is stored on Amazon S3 and Redshift using the AWS Glue catalog. Once the data is in your data lake, you can use engines such as EMR for processing this data and Amazon Athena to analyze this data. The one thing that we want to note here is that the data lake has a data catalog with AWS Glue, which can be shared across your storage services such as Amazon S3 and Redshift, as well as the analyzing engine such as Athena. So where does the data lake start? Any guesses? Data lake starts with, yes, security. You guessed it right. As with everything at AWS, we always start with security. This is what differentiates AWS. Without security, there will be no trust. So what does security mean? Data needs to be protected, and it is the foundation of modern data lake. Amazon S3 provides the best security, compliance, and audit capabilities. It is the cloud storage offering that gives control at the object level, not just bucket level. This allows companies to apply access, logging, and audit policies at account and object levels. S3 supports 3 different forms of encryption, including automatic server-side encryption, encryption using keys that are managed by the AWS Key Management Service, also known as KMS, and encryption with keys that customers manage. It offers data encryption in transit while replicating across regions, and it lets customers use separate accounts for source and destination regions. This protects against malicious insider deletions. S3 also helps security teams proactively monitor, detect, and alert anomalies with Amazon Macie, an AI-powered security service that helps detect early stage of attack. Amazon Macie uses machine learning to automatically discover, classify, and protect sensitive data in AWS. Amazon Macie recognizes the sensitive data, such as personally identifiable information, that is PII, or intellectual property, and provides you with dashboards and alerts that gives visibility into how this data is being accessed or moved. The fully managed service continuously monitors data access activities for anomalies and generates detailed alerts when it detects risk of unauthorized access or inadvertent data leaks. Macie is a service to facilitate compliance. The first step towards building compliance policies, including GDPR or General Data Protection Regulation, is around identifying where sensitive data exists across an organization. Macie automates this discovery phase with highly accurate machine learning based detection of over 70 different data types related to PII or personally identifiable information, regulatory documents, API keys, and secret key material. Macie analyzes activity of user application and service accounts associated with sensitive data that suggest risk to the business, such as inadvertent exposure of data, insider threats, or targeted attacks. Macie can alert on suspicious activities such as compromised user accounts, enumerating and downloading large amounts of sensitive content from unusual IP addresses, or the download of large quantities of source code by a user account that typically does not access this type of sensitive content. A compliance-focused example of Amazon Macie includes detection of large quantities of high-risk data shared publicly or to the entire company, such as files containing personally identifiable information, intellectual properties, legal or financial data. Macie has a dashboard to define their own alerts and policy definitions based on their security needs. Just like water in a lake, in your real life, there is always, you can hear the waves and the water is always in motion. Similarly, the data in the cloud on a data lake can hypothetically hear this motion. What could be causing this? Well, the answer is some of you have guessed it right. It is the data preparation activity. A recent study by Crowdflower surveyed about 80 data scientists about their jobs. They found data scientists spend 60% of their time on cleaning and organizing data. Collecting data sets comes around at 19% of their time, meaning that the data scientists are spending around 80% of their time in preparing and managing data for analysis. They also found that data preparation was the least enjoyable parts of the work. Surprise, right? The question we have to ask ourselves is if we can make this data preparation easier, if not enjoyable. Can we minimize the time that people are collecting data sets and cleaning or organizing their data? As we see, one of the most critical aspects of modern data lake is data preparation. It needs to be simple, flexible, and well controlled from compliance perspective. Enter a very important component of marketing data lake, AWS Glue. AWS Glue automates much of the effort in building, maintaining, and running ETL jobs. AWS Glue crawls your data sources, identifies data formats, and suggests schemas and transformations. AWS Glue automatically generates the code to execute your data transformations and loading processes. AWS Glue is serverless. There is no infrastructure to provision or manage. Glue handles provisioning, configuration, and scaling of the resources required to run your ETL jobs on a fully managed, scaled-out Apache Spark environment. You only pay for the resources used while your jobs are running. Glue is integrated across a wide range of services on AWS, meaning less hassle for you when onboarding. Glue natively supports data stored in Amazon Aurora and all other Amazon RDS engines, Amazon DynamoDB, Amazon Redshift, and Amazon S3, as well as MySQL, Oracle, Microsoft SQL Server, and PostgreSQL Server databases in your virtual private cloud or VPC running on Amazon EC2. Glue provides out-of-the-box integration with Amazon Athena, Amazon EMR, Redshift Spectrum, and any Apache Hive Metastore compatible application. Amazon Athena is an interactive query service that makes it easy to analyze data in S3 using standard SQL. Athena is serverless, so there is no infrastructure to manage, and you only pay for the queries that you run. Athena is easy to use. Simply point your data in Amazon S3, define the schema, and start querying using standard SQL. Most results are delivered within seconds. With Athena, there's no need for complex ETL jobs to prepare your data for analysis. This makes it easy for anyone with SQL skills to quickly analyze large-scale data sets. Athena is out-of-the-box integrated with services such as Glue and the AWS Glue data catalog, allowing you to create a unified metadata repository across various services. Crawl data sources to discover schemas and populate your catalog with new and modified schema and partitions, and maintain schema versioning with Glue crawler. And now you can query that data with Athena. You can also use Glue's fully managed ETL capabilities to transform data or convert it into columnar formats to optimize cost and improve performance. As we see, there are a lot of components in a modern data lake. So what are the ways of simplifying things? Simplification is the key pillar of modern marketing data lake. What are other AWS technologies which keep marketing data lake simple? Emerging serverless analytics stack, when you can put all data lake systems together with zero infrastructure to manage, all enabled by serverless services and Lambda functions. This lets you pay per use with close to zero cost when things are ideal. It scales automatically. Systems are highly available and fault tolerant by default. We also deliver our AI ML services this way. While we offer GPUs and frameworks for experts, we also make high-level services for image and video analysis, transcriptions, translations, etc. available via APIs with nothing for you to manage. Simply put, we do a bunch of work behind the scenes so you don't have to. Let's take a look at a couple of customer examples or marketing and advertising data lakes. DataZoo is a digital marketing platform which uses AWS services to process 90 billion messages daily with peak 2 million requests per second. The repository exceeds 10 petabyte of data stored and analyzed with over 200 terabyte new data daily. Deployed in 13 AWS regions, which operates 24/7 and having a savings of 72% over on-premise infrastructure. The DataZoo data lake ingests real-time data feeds from several sources through Kinesis, and then the data is passed to Apache Spark running on Elastic MapReduce. After the data is processed, enriched, and organized, it is placed in S3 for further use by various reporting tools. Another example is Annalect. Annalect is one of the leaders in digital marketing, built a data lake solution on AWS. It consumes data from a number of sources, social campaigns, ad server logs, as well as ingest first-party advertisers' data. The simplified diagram shows a distinct pattern of two data repositories, with a raw data and query-optimized and curated data. Glue is transforming the data and managed through data catalog. The data is loaded into Redshift for analytics. Finally, GroupM, this is a very similar architecture to the previous one, except the ETL process is performed by a third-party ETL tool from a partner called Matillion. The benefits are faster time to market, scalable querying with Redshift Spectrum, and choice of a third-party tools for visualization and analytics. Now that we have seen the different services that we can use for the marketing and advertising data lake, let's look at the economics of the data lakes. Handing over to Dimitri.
Thank you, Hemant. So we know that we can scale data lakes into multiple petabytes. So how can we make it much more economical at large scale? So let's dive into the details of that. Storing large and growing volumes of diverse data can be costly, with a lot of infrastructure to acquire. But data lakes built on AWS are the most cost-effective. AWS offers tiered storage classes, which makes data lakes cost-effective from storage perspective. Cold data that is infrequently used can be moved into Amazon Glacier, which provides long-term backup and archive at very low costs. So Amazon S3 management capabilities can analyze object access patterns to move infrequently used data to Glacier. And it can be done on demand or automatically with lifecycle policies. Glacier also offers immutable data locking controls that help support compliance. Running analytics on data lakes can be expensive and time-consuming. And because large amounts of data are stored in objects, each query returns the entire object, regardless of what's needed. So Amazon S3 has a feature called S3 Select, which uniquely retrieves only subsets of data within an object, leading to much faster querying of up to 400% faster and at dramatically lower cost. For customers that want to query archived data, Glacier provides Glacier Select, a similar capability to S3 Select, allowing customers to query and retrieve archived data on demand and extend the analytical capability over the data lake to include archival storage. So how do you save money on the compute? You can begin querying the data with Amazon Athena for as little as half a cent per gigabyte queried. Other analytics and machine learning services are priced with pay-as-you-go approach for the resources you consume. So this ensures that you're only paying for what you use and you have no wasted capacity. AWS takes this concept a step further with EMR and Athena, which can automatically scale resources when job completes through auto-scaling in EMR and using AWS Serverless platform for Athena. EMR provides multiple ways of lowering your bill, further by committing to a term and saving up to 75% using EC2 reserved instances. And you also can run your clusters on spare AWS compute capacity and saving up to 90% using EC2 spot instances. So this is a unique capability of AWS data lakes. So for curious minds, we have a set of technical resources to review. So as a next step, you can take a look at a solution which is called Data Lake on AWS. AWS offers pre-built, ready-to-use building blocks, and Data Lake is available for your testing. It can be automatically deployed via CloudFormation template, and it can be done with just one-click deployment. You can follow the link on the slide. We also have a training class for building serverless data lakes on AWS. It's available for training in public or private cluster environment. And finally, several deeper technical resources, all with code examples which you can try out. They cover important aspects of data lake building and frequently encountered in digital marketing and advertising data lakes. Feel free to check those resources out. So thanks so much for being with us today and listening to this webinar, and we look forward to hearing your feedback and continue our conversations about data lake and marketing and advertising.